We have here an apparatus that will show the refraction of light as light travels between air and water. So let's give it a try. Now I'm using a rather powerful laser. Please be careful when you use such lasers. Never point it at the eyes of any person. Let's give it a try. Now I have put some powder in the water so that the light rays will be more visible. So as you can see here, let me try to get the best angle. Okay, you can see that the light ray is traveling from air to water, and light is being refracted towards the normal, right? This angle being the angle of incidence, and this angle being the angle of refraction. You can see that the angle of incidence is larger than the angle of refraction. That's because when light enters an optically denser medium, in this case water, it will slow down, right? And as it slows down, it bends towards the normal. The normal being, in this case, the 0 degrees, right? So light slows down when it enters an optically denser medium and it bends towards the normal. So what if I'm directing the light from water to air? Now when light travels from water to air, you can see over here that the angle of incidence is smaller than the angle of refraction. That's because light speeds up when it goes from an optically denser medium to an optically less dense medium. So when it speeds up, it bends away from the normal. Now you can also see a faint reflected ray within the water. As I increase the angle of incidence, now at about 49 degrees or so, the angle of refraction increases until it's about 90 degrees. Now when the angle of refraction is 90 degrees, the angle of incidence is called the critical angle. And beyond the critical angle, as I increase the angle here, you can see that the light is totally reflected. So when light travels from an optically denser to less dense medium, and the angle of incidence is greater than the critical angle, there will be total internal reflection.